Moving on, so we have covered logging, we have covered global counters, we have covered PCAPs. After leveraging all these techniques for to troubleshoot the issue, we still need, deep inspection, what's exactly happening, and we are not able to figure out. At this stage, we can take flow basics, which uh, is really verbose, and it's going to give you a lot of additional info which we don't see in the monitor logs, don't see in the PCAP, don't see in the global counters. And we want to see what exactly the firewall is doing to that particular traffic, line by line, just like you are giving direction to someone. It's the same thing. The packet received, what the firewall is doing. So I will be showing you how the flow basic is taken and how we can leverage it and how we can examine it. So what is the purpose of flow basic? It is used to troubleshoot typical scenarios where we don't have, enough information using the monitor, PCAPs, and global counters. That's where we can take the flow basics. Remember, it's CPU intensive, so every time you try to take it, just be very careful and don't run it for a very long time. Just run it for like 1-2 minutes, and once the session is recorded, just disable it, because it's a CPU intensive, so always keep that in mind. Okay, so the visibility that is provided by Flow Basic, it provides you info from layer 2 to layer 4. So slow path, the fast path. So the major difference between slow path and fast path is slow path is for the new sessions which are hitting the firewall for the first time, and fast path is the sessions where we already have a session, but existing session traffic is coming again to the firewall. But the rules are evaluated every time. But slow path is a little slower because it does a lot of checks. But for the fast path, since we already have a session running, we can skip a few of the checks. It is also used during NAT, DOS, and initial security policy matches, used during session close, reset, and packet drop actions, and also give information about forwarding lookups, that how the firewall is looking for the egress interface based on the destination, and how the traffic will be forwarded out using which interface, physical interface. And it can also give you information about the layer 2 to layer 4 addressing, TCP information, and the session numbers. Yeah, just a minute here. Let me adjust this. Okay, so Flow Basic provides a lot of information, but some information is not provided. Flow Basic is a flow-oriented debug feature. Thus, the information it provides is directly related to the layer 2 to layer 4 process that are required to facilitate the bidirectional flows of traffic that belong to each session. Layer 7 policy matches based on packet payload pattern matching, such as app ID and threat detection scanning, are not provided. So it's mostly used from layer 2 to layer 4, and the content inspection and app ID detection, threat detections, you won't see that information here because it's all layer 7. You can see evidence of content based activity, but Flow Basic generally does not report directly on them. Flow Basic output can be difficult for to understand at first, but as you get used to it, keep seeing it, using it, then you can easily interpret what exactly the output is telling you. Okay, so this is the command to enable the flow basic. Debug data plane packet diag set log feature flow basic. This is the command you can use to run this. So it's a combination feature set, flow and basic of the packet level diagnostics capability of the firewall debug tool. Once flow basic is configured and enabled and debug logging is turned on, flow basic provides detailed logging for individual packets as they move through each of the major stages of the firewall. So ingress stage, session setup, security processing, fast path, slow path, and how the packet is actually egressing. So you can see there are a lot of options here, but we normally use to enable the flow basic, and all other features that can be enabled as well, but it's very rare, and unless engineering tells us okay enable this, we don't do it. So normally we just stick to the flow basic. Okay, to enhance the visibility, we can correlate everything in from the monitor logs like the session ID, the packet captures, enable the flow basic, check the counters. So we have to correlate everything together when we are troubleshooting it. So if we are still not able to figure it out, we just collect the flow basic and open that log file in the notepad and then see what exactly is happening with that traffic. Is the firewall dropping it? If it's dropping it, why it's dropping it? If not dropping, then what is happening with that traffic? So there's a lot of verbosity that can be read in the flow basic logs. So the correlation is very important. If you are not correlating all the info being recorded while troubleshooting, then it will not make sense. So you have to have few things in writing, like what traffic it is, source, destination, port number, session ID. So, and based on that, you can find that session in the packet capture, and using the identifier, you can look for the flow basic logs. So there has to be something common which you are tracking. We can't just keep looking the flow basic file uh, without having anything concrete that is common. So we have to look for identifier of that traffic, compare it with the PCAP and the flow basic log file, so that everything will make sense and we can easily correlate. Recommendation. So this is a basic recommendation before we capture everything. Clear all the old settings. Use the narrow filter as narrow as possible because this is a CPU intensive. Okay, so over here we are talking about the PCAP filters. Configure the stages, enable flow basic, check the sessions, turn on capture, then logging, monitor capture, turn off logging, then capture, view flow basic log, view PCAPs. So this will, I'll show you one by one so it will make more sense. Okay, so this is the command to see what packet diag setting we have. Okay, so I'll show you that quickly in the CLI. Okay, so once you run this command, it will show you what packet filters you have. So this is at index 1. So this is the same thing we were setting in the GUI under ID. I just put 1. You can have up to 4. Okay. Packet filter enabled, no. Match pre-pass setting, we normally don't enable this. Okay, logging, is it enabled? No. Okay, so once we enable the logging, we will start seeing it over here. Okay, so I'll show you that also in a moment. Packet capture, it's not enabled at this moment, no, but we have our staging configured. Okay, so the file name rxfw rxdp. This is the same thing which we see in the GUI, except this logging part, which is only visible in CLI. All right. Okay, so always start from the beginning. Check for the old packet dike settings. If, let's say, one firewall is managed by multiple administrators, so they can have or they may have left old settings which you don't want. So by running this command, you can see the settings. You can clear all the settings and you can clear all the logs. Okay, we want to start fresh, start from the beginning, and we want to capture everything. That's the goal. Okay, configure narrow filters and enable them. So this is again the IDs. Okay, and this is the filter on. This is the step 2. Then once you are done with it, you can verify with this command. It's optional because you will see that in the GUI anyway. Okay, then analyze the global filter, and by running this command you can see the packet rate and how many different counters are being hit since you last ran the command. So think of it as this is this goes all together. It's not like we are doing one part at a time. You have to combine everything to narrow down the issue. Okay, so at the same time we are seeing the monitor logs, we are configuring the packet captures, we are leveraging the global counters, and then we are implementing flow basic. So all of this goes hand in hand. It Yeah, we don't do one thing at a time, you have to do it cumulatively. Okay, so step 3, set the stages: receive, transmit, drop, firewall, enable the log features. So this command at step 4 will enable the flow basic feature. Okay, so once we do that, we can see that in the CLI it's enabled, and then you can again check it by seeing the show setting. Okay, and you can always clear the filter mark session. This is optional. Uh, let's say if you are trying to do a flow basic on same packet filter, in those cases you can just clear it completely so that everything will be recorded from the start. We don't want to see anything old. Okay, step 6, we turn on the packet capture, and with this command, debug data plane packet dike set log on, this will turn on your flow basic. Okay, then we can monitor the progress, show filter mark session. This command, debug data plane packet dike show setting, it's if you notice, we keep running it in the CLI every time we are doing something. It's for the confirmation. Okay, just to see how we have configured everything. We don't want to jeopardize the system by by putting a lot of pressure, because it could be a production hours. So we keep verifying it by doing a packet dike show setting. Okay, once done, you can turn off logging and then turn off packet capture by running these commands. Packet dike set log off, this will turn off flow basic. Then you have to turn off packet capture, and then you can turn off the filtering. There is a warning: do not turn the filter off until you turn logging and capture off. So always keep that in mind, because filter is a thing which is very specific and narrow, and we are instructing the firewall that whatever you are trying to do, just do it for this traffic. All the advanced troubleshooting we are trying to do, just do it for this traffic which is mentioned in the filter. We don't want to do anything for broad traffic. Okay, so this filtering is really important. Keep that in mind when you try to dig deeper and you think about, okay, going that route, and you have to take flow basic. Always put the filter. It's very important. Okay, once the flow basic logs are done, you have reproduced the issue, everything is traversed through the firewall. You have to run this command to aggregate the logs, and to verify, you can run this command less dp log pan packet diag log. So it depends on the platform. If it's pa 200, 220, 500, because there's no separate dp on these hardwares. So in that case, you have to see under less mp log pen packet type log. If you have other models, you can always see that under the specific dp. Okay, and if you want to see that in the GUI, sorry, in the CLI, you can run this command for just to view the PCAP. No DNS lookup yes filter PCAP. Okay, interpreting flow basic output. So let me just show you the settings. So it's just a GUI and CLI comparison here. So the filter will look like this. Enable yes. So this on is equivalent to it. Pre-pass is off. So sorry about that. Set to no. So it's off. This is index 1, index 2. So this is this packet capture filter, ID 1 and 2. This, so it's a comparison how things will look like in CLI compared to GUI. Then logging is enabled. Yes. So this is the command where we enable the flow basic, and once you enable it, you will see under features that a flow basic is enabled and logging is yes. So that's how you see what feature we have enabled here. Okay, with this command. Let me go back. Debug data plane packet diag set log feature flow basic. So we turn the feature on, which is flow basic, and with this command, step 6 second command, debug data plane packet diag set log on, we enable the logging. Okay, and then it's again packet capture enable yes, packet capture on, same thing. And what are the files captured? So all staging is here, how many packets we have captured. Okay, if you ever plan to view a PCAP in the CLI, you can do that. View PCAP, no DNS lookup, yes, filter PCAP, and the file name. So in this case, we can see that 1.20 trying to talk to 50.10. So that's a sin. But for the return traffic, I see the different IP. So 50.10 is talking to 16.16, not 1.20. So why is that? It's because of the NAT. So natting is happening and the response is coming for this. And remember, so think of the firewall has left hand and right hand. So from the left side, you can transmit and receive. And at the same time, from the right side, you can transmit and receive. So if firewall is a reference point here, so the traffic can go out, can come back from both sides. So yeah, so think of it as we can send everything from the left hand side and receive everything from the left hand side, and same goes with the right side. So receive and transmit. So when you try to check the files here, you will see the same information. So this receive here is whatever we are receiving from left hand side and right hand side. And this transmit here is whatever we are transmitting from the left hand side, right hand side. Okay. So that's why you see the same thing here again. We received it and then we forwarded it. So, and this IP is because of the NAT. Okay, so this is how the flow basic log looks like. Okay, this is the ingress stage. The packet is trying to enter the firewall. Okay, at this stage, there's no tag because this is the first packet. You can see info like packet length, port 17, interface 17. What VSys is it? Okay, it's this is WQE in a work queue index. So this is internal to the firewall, and this is also internal hex value. And then we have a layer 2 info. This is the MAC address, source and destination MAC address. IP 1.20 trying to talk to 50.10, protocol 6, which is TCP, version 4, IPv4. So these are different IPv4 header information. Okay, header length, TOS length, ID. This is one of the header field in the IP layer, which is to identify the traffic. So in this case, the ID is 7991. And so you can see we are also including the header information here. What is the TTL? So you can see how powerful it is. It's giving you entire picture of the packet that is trying to enter the firewall. TCP port, source port, destination port, and then you have basic TCP stuff, sequence, window size, checksum, what flag is it? This is a SYN, first packet TCP, so it is obvious it will be SYN. And yeah, all the options are available here. So flow lookup is happening here, keyword. So this is also, you don't have to worry about this value. And the firewall is saying during the session setup, I haven't found any active flow. Okay. So in this case, what firewall will do, it will try to create a session. Okay, so the packet number in the work queue index links to the next stage record, which this is the ingress stage. So if it goes to the next stage, uh, this work queue index will be linked to all the stages. Okay, so ID field of the IP header will match a packet in a PCAP. So if you try to find the same packet in the PCAP, you have to focus on this ID. So this is IP packet identification, which is part of IP header. And the flow key links to the next ingress packet from the same source. So in this packet, in this output, the most important thing we have to keep in mind is the ID, which is 7991. This will be used to correlate the traffic in the PCAPs and in the monitor logs. Okay, for the slow path, this is how it will look. The packet received at slow path stage. So now we see the tagging information here. Okay, so over here, there's no tagging. Now there's a tag, type atomic. Don't worry about these values. Just focus on the layer 2 information, the IPs. So if you open this file in the notepad, you can just search doing control F and look for this IP address. Once you can search for this IP address, you can map it to the ID, which is 7991. So remember, the first thing to locate is the IP address and then the ID, which you will use later in the PCAPs to identify the same traffic. Now, this ID could be in receive stage PCAP, transmit stage PCAP, but because we know this is a slow path, so it will be in the receive state, but you can investigate all the packet captures using this ID. It could be in drop. So remember, this ID is the key when you are trying to compare. Okay, so again, we see the TCP information here. All the TCP options are mentioned here. Session setup, it's part of VSys 1. PBF lookup with application browsing. Just a minute here. I'll explain why it's talking about the PBF here. Okay, so in this particular example, the policy-based forwarding lookup is made with application web browsing only because there's a match in the application. So it has matched it compared to the application cache from a previous session, from the previous session, and the application timeout is 60 seconds. So it hasn't timed out. That's the reason. Otherwise, yeah, you won't see it. Okay, so session setup, PBF lookup with application web browsing, session setup, ingress interface. So it has hit the firewall on this interface. Egress interface 1/3. It is giving you the zone information also. So remember the tuples we have for identifying any session on the firewall: source IP, destination IP, source port, destination port, protocol, and ingress zone. We use 6 tuples. Normally it's 5, but on Palo Alto firewalls, we use the zone information also. Then net policy lookup is happening. It has matched rule index 1. So it depends on at what in the order at what position the rule is, and it will pick it up from the config. Policy lookup matched rule index 0. So it has picked index 0 rule. So over here we are seeing 1 and 0, but in the GUI you must have a name associated with them, like allow DNS traffic or allow internal traffic or global protect users, but it just using it as an index. Okay, we have allocated a new session ID 45969. This session ID will you can see in the monitor logs. Okay, and this ID 7991, it will be used to map it in the packet captures, and this is the firewall session ID 45969. Okay, so it's giving you information about the rule index 1, name, source NAT to DMZ. This is the NAT rule it has hit. Okay, and then packet matched source NAT to DMZ, which is index 2. It is also showing you how it is did 1.22 172.16.16.16, and it has created session in queue to install. So this is how the slow path will actually look like. Okay, let's move on to fast path. So this is the fast path, packet received at fast path stage. So if you compare the tags here, this has 364. Okay, so this tag is not making sense here. But when you see allocated new session 45969, you will see the same tag here. So it is using that the session ID as a tag here to just to identify that traffic as a fast path traffic. Okay, so 45969 again, same, all the information is same, layer 2 IP TCP, flow fast path session. So we already have the session, existing session. So it has looked it up, and 45969, it has found the session and it has declared it as a part of fast path because of the same session ID. Okay. How the forwarding will look like? The forwarding will happen every time. It doesn't matter slow path, fast path, because routes can fluctuate, or you know there are other issues related to the routes. So firewall does the forwarding lookup every time. Okay, so forwarding lookup happened here. It found ingress interface 17, and it is telling us L3 mode virtual router 1. So this is the virtual router we are using. Route lookup happening in virtual router 1, IP 50.10. This is where we are trying to go. route found, interface, Ethernet 1/3, zone 3. We are resolving the ARP also for that, and then we transmit the packet on port 80. So this is how it will look in a flow basic log. Everything is line by line, so these logs cannot lie. It will just give you the real picture of the packet. And when the session is closed, we can see that the flow, everything else is same. We are just flow action close for session, flow actions and data. It will just tell you how the session is closed. Okay. And all these block pages you will see under a transmit PCAP. So if you ever have to deal with those, just look for those under the transmit PCAP. Okay. So normally the transmit PCAP, most of the stuff is already done, like the natting, lookup, pre-nat, and everything. Most of it is already done. So maybe that's why we see that in the transmit PCAP. Like this is one of the example of block page responses. So remember I told you about that uh, the packets which are initiated by the firewall, not through the box traffic, but they are generated as a response by the firewall. So those will be seen here. So this is one of the example of response which is generated by the firewall. So this user is trying to access something malicious and we have blocked it. So this block page is actually generated by the firewall itself, just to let the user know you are blocked. Okay. But if you compare it here in the output, you won't see anything different here, which will tell you, okay, why this page is generated. We see that it's using the same tag. Forwarding lookup happened, route lookup happened. Yeah, there's, so just to correlate this with the actual PCAP, you have to leverage the IP identification, and that will give you more information. So compare that ID. In this case, it's 4058 in the packet capture. So you can put a identification, a filter in the Wireshark, and you can find this ID. So remember, this ID is very useful when you are comparing flow basic with the packet captures.